Our galaxy, the Milky Way, is a barred spiral galaxy containing hundreds of billions of stars, including our Sun. It has a central bulge surrounded by a flat rotating disk with spiral arms extending outward and a surrounding halo of stars, star clusters, and dark matter. The Milky Way spans about 100,000 light-years in diameter and is part of a small group of galaxies known as the Local Group. It's thought to be about 13.8 billion years old and is continuously evolving through the processes of star formation and galactic collisions.
The Milky Way is a barred spiral galaxy, characterized by its distinct spiral arms, a central bulge, and a halo. These components are key to understanding the galaxy's overall structure and dynamics. The Milky Way's spiral arms are regions of higher density that wind outward from the central bulge. These arms are home to many young, bright stars, nebulae, and star clusters. They are typically organized into several major arms and their associated minor arms. The main arms of our galaxy include the Perseus Arm, the Scutum-Centaurus Arm, and the Carina-Sagittarius Arm. These arms are not static, but are part of a dynamic system that is constantly changing due to gravitational interactions and star formation. The central bulge of the Milky Way is a densely packed region of stars located at the heart of the galaxy. It is roughly spherical and contains older stars, including many red giants. The central bulge is also thought to harbor a supermassive black hole known as Sagittarius A, which has a mass of about 4.1 million times that of the Sun. This black hole plays a significant role in the dynamics of the bulge and the galaxy as a whole. Galactic halo. Surrounding the disk and bulge is the galactic halo, a sparse, spherical region populated by older stars, globular clusters, and dark matter. The halo extends well beyond the visible components of the galaxy and contains a significant amount of the galaxy's mass, though much of it is in the form of dark matter that does not emit or interact with light in a detectable manner. Galactic disk. The galactic disk is the flat, rotating region that contains the majority of the Milky Way's stars, gas, and dust. It is where most of the galaxy's star formation occurs. The disk is organized into a thin, central plane with a more diffuse outer layer. The presence of interstellar gas and dust in the disk contributes to the formation of new stars and planetary systems.
Formation and evolution. The Milky Way's formation and evolution are complex processes that have unfolded over billions of years. The current understanding of its development involves several key phases. Early galaxy formation. The Milky Way began forming shortly after the Big Bang, which occurred about 13.8 billion years ago. Initially, the galaxy was a vast, hot cloud of gas that began to cool and condense under gravity. This process led to the formation of the first stars and clusters. These early stars contributed to the formation of the initial structures within the galaxy. Accretion and mergers. Throughout its history, the Milky Way has grown through the accretion of smaller galaxies and the merging of cosmic structures. Evidence suggests that the Milky Way experienced several significant mergers with smaller galaxies, which contributed to its current structure. The remnants of these mergers can be observed in the form of stellar streams and satellite galaxies. Formation of the disk and spiral arms. As the galaxy evolved, the formation of the disk and spiral arms occurred due to the conservation of angular momentum. The rotation of the galaxy caused the gas and dust in the disk to settle into a more organized structure, giving rise to the spiral arms and the overall disk morphology.
In recent times, the Milky Way has continued to evolve through interactions with nearby galaxies, such as the Andromeda Galaxy, also known as M31. In about 4.5 billion years, it is expected that the Milky Way and Andromeda will merge, forming a new larger galaxy often referred to as Milkomeda or Andromeda Milky Way.
The Milky Way is a dynamic system with complex motion patterns. Stars within the Milky Way follow various orbits around the galactic center. These orbits can be roughly circular or more elliptical, depending on their distance from the center and their velocities. The movement of stars within the galaxy contributes to the overall gravitational structure and the distribution of mass. Galactic rotation. The Milky Way rotates as a whole, with stars and other matter orbiting around the galactic center. The rotation curve of the galaxy reveals that the outer regions of the galaxy rotate faster than expected based on the visible matter alone, suggesting the presence of dark matter in the galactic halo. Dark matter. The presence of dark matter is inferred from its gravitational effects on the rotation of stars and the dynamics of the galaxy. Dark matter is thought to make up a significant portion of the Milky Way's mass, though it does not interact with light or other forms of electromagnetic radiation. Galactic disk dynamics. The galactic disk is subject to various dynamical processes, including spiral density waves, which affect the distribution and motion of stars and gas within the disk. These waves contribute to the formation and maintenance of the spiral arms.
Observations and studies. Understanding the Milky Way relies on a combination of observational techniques and theoretical models.
Observational methods. Observations of the Milky Way are conducted using a range of telescopes and instruments, including radio telescopes, optical observatories, and space-based observatories. These observations provide data on the distribution of stars, gas dust, and other components of the galaxy. Stellar surveys, like the Sloan Digital Sky Survey and the Gaia mission, have given us incredibly detailed maps of the Milky Way's structure and stellar populations. These surveys are essential for refining our understanding of the galaxy's composition and dynamics.
Computer simulations play a crucial role in modeling the formation and evolution of the Milky Way. These simulations use physical laws and observational data to create virtual models of the galaxy, allowing scientists to test hypotheses and predict future behavior. Despite significant progress, many aspects of the Milky Way remain elusive. Research is ongoing to better understand the nature of dark matter, the exact processes behind spiral arm formation, and the detailed history of galactic mergers and interactions.
The Milky Way Galaxy is a complex and dynamic system, offering valuable insights into the structure and evolution of galaxies. Its spiral arms, central bulge, and surrounding halo each play a role in shaping the galaxy's overall appearance and behavior. The study of the Milky Way not only enhances our understanding of our own galaxy, but also contributes to the broader field of astrophysics and cosmology. As technology and observational techniques advance, our knowledge of the Milky Way will continue to expand, revealing new aspects of its formation, structure, and future. This essay provides a comprehensive overview of the Milky Way, touching on its structure, formation, dynamics, and current research. It highlights both our current understanding and the ongoing questions that drive scientific exploration.